In this episode, I've got a Sony CDPX111ES. This is a high-end ES CD player that Sony produced in about 1991. And this one is apparently not loading discs correctly. So it could be a couple things that cause this problem. So let's take a look and see what's causing it and see if we can get the problem rectified. The customer's complaint is it's got a problem with the door opening and closing. He says it won't stay open, although it appears to be staying open now. But more than likely, oh yeah, the belt is slipping. More than likely, it needs a new belt for the open close. Oh, there we go. It just opened on its own. See? There's the problem. It won't stay closed. So more than likely, it needs a new belt. It probably also needs the door sense switch to be serviced. More than likely, the contacts are dirty. So let's open the unit up and see what the problem is. Note that there is a small ding here. I did not cause that. This one's from a local customer. He dropped it off this morning. I do have a couple of other things here to work on that I'll be getting to today and tomorrow, including a big amplifier that I've been sitting on for the past week or so. Just haven't had time. Trying to get all the small things out of the way. In the top of this unit, there's an anti-resonance material. I think it's a piece of steel on this one. Yeah, there's a piece of metal that's been glued down to the inside. This is to give it a bit of weight, but also this is to stop the cabinet from resonating. So this is one of the tricks that the manufacturers used, was they took another piece of metal and they glued it down, because even though the metal itself is flexible, the bond of the glue is actually what stops the resonance of the metal when it's playing in a loud situation, like a loud environment. Here's the inside chassis to this unit here. As you can see, it's mostly an empty box. Even though this is an ES unit, they've done is they've separated the transport from the electronics. It's got a separate transformer power supply, linear power supply, not a switch mode like a lot of the stuff migrated to. Linear power supplies, we like them because they're a lot less problematic than switch modes, and they produce less noise. Optical pickup on this unit is a standard KSS 240, and as you can see, the tray is open. What I'm going to do first is I'm going to remove the front. Turn off the power first of all. I'm going to remove the front nose piece. Just slides off that way. I can remove the mechanism so that I can see what's going on with the mechanism itself. On these units, there's typically a leaf switch and a belt. Belt opens and closes it, but there's a leaf switch that detects when the drawer is fully extended and when the drawer is fully closed. Just going to release the mechanism first so that I can investigate. One more screw at the back. Now I can lift the mechanism out. We want to be careful with that ribbon cable. Here is the mechanism itself. The switch I'm talking about, there's a switch right here and another switch over there, I think, on this one. And here is the motor that opens and closes the CD drawer. So if we power it up, let's just see what it's doing. Open. Yeah, the belt is slipping. I can hear it. And that's what the problem on this one is. It's just the belt is slipping. We'll clean the switches on it as well, but the belt is right down here. We can see it. It's relatively easy to access, but of course there is a gear here in place. So to do this right, we do need to remove the top clamp and the disc tray itself. First things first, we will unplug the main unit itself, the power supply unit, the audio board from the disc transport. That way I can work on the disc transport without risk of damaging the flexible ribbon cable. We all love these things because they're so darn easy to damage if you're not careful. You can tear them or cause the conductors to separate from the plastic base. Some of these were better than others, and these ones here were ones that were quite easy to damage if you weren't careful. To remove the disc clamp, there's a couple of just plastic tabs we can just push in here to release on either side, and this will remove the disc clamp assembly itself. It just lifts off. Once that's lifted off, we can just lift off the tray. See, real easy to get to these ones here. Lift off the gears, and here's the belt that needs to be replaced. These are the switches I was talking about. They're just leaf switches. We're going to clean these switches up as well and make sure that they are not causing a problem. One switch is used to detect when the tray is open, and the other one is used to detect when the disc tray is fully closed and latched. And without the switches working properly, the unit will typically either open and close, or it will close and then open. And the reason it was opening was because the belt was slipping. Right, the belt here, this belt is pretty much shot. I'm pretty sure I've got one that will fit. But as you can see, this belt here, I can turn quite easily, stop the motor from turning. The belt will just slip around here. So I got to go through my collection of belts, and I'm sure I'm going to find one that is going to be suitable to work with this unit. Okay, I have a little smaller belt here. See how this one goes in. See how the torque is on this one. Yeah, this one's a little stronger torque. Okay. Put the gears back on. I should clean these switches that's on here. Probably the easiest way to clean these switches is actually to remove the motor, because the circuit board they're on is mounted here on the motor. So we'll drop the motor down. My lift cam fell out, so we're just going to reinstall the lift cam. This is what lifts the optical pickup into place, and it's quite easy to reinstall. It only fits in one way. You actually have to lift the mechanism up first, and it will slide into a groove just like that, and that's what lifts the mechanism up and down. Unplug. I was going to pop the tops off these switches so that I can clean them. A couple different ways you can clean these switches. One of them is to use just some deoxit on them, or you can use a piece of paper. We can place some deoxit on a piece of paper, open up our switches, and wipe the contacts. That's one way of doing it. Put the paper between the switch contacts and squeeze them together and pull the paper through, and that will take some of the oxidation off the contacts. It's one way of doing it. And then put the switch back together and do the same for the other. Take this one apart, same way. I can put the switch assembly back in. How this operates, of course, is the gear meshes with this J-shaped gear on the bottom. So as the drawer gets pulled in, the motor continues to operate, which causes this cam to spin around like that, which is what raises and lowers the disc. This is why if the belt starts slipping, and I see this little cam here is what operates the switch. This switch is affected by the tray. When the tray is all the way out, it pulls the switch closed. And when the cam raises the disc, this little arm closes this other switch. That's how this operates. So providing that the belt that I put in has got the correct amount of tension on it, just drop this back in place. And put the top cover on. There we go. That's on. Top cover drops in place like that. And now the unit is ready to be tested. We'll see if that belt that I dug out of my belt bin is sufficient. If not, I'll have to find one that's a little bit smaller, but that one there is probably more than sufficient. It's pretty close to the original size of the original belt. Next, I'll plug in the ribbon cable again. Line it up and push it in straight, and then I can put the mechanism back in place. Now I can test it before I reassemble everything. All I have to do is just make sure that the alignment is correct and that the disc tray is sitting in the correct position. Now I can power it up and we'll see whether the system will load and unload. So the disc tray is open. And you can see the lasers attempting to focus. So I know that the belt is not slipping. The belt I've replaced is the correct one. Just mount the chassis again. And then we'll test the CD player, make sure everything's working. I can give the guy a call and tell him his CD player is ready. Put the tray back on the front, or the cover, I should say, on the front of the disc tray. Snaps on like that. Okay, let's test this thing out. Neat thing about these is they had both fixed and variable output. So if someone had a nice power amplifier without a remote control, they could use the remote that came with the CD player to adjust the volume. Grabbing one of my Music Bakery CDs. So I've connected to the variable line output. These were a really nice CD player. The fact that they had direct access. So if I wanted to go to track 14, for example, I could just push the button 14 and it would queue up to track number 14. This has got 18 tracks on this disc, so I punch the track 18. It will play track 18. Track 5. Nice display, nice blue or almost a whitish blue vacuum fluorescent display. Nice unit. And of course it's got the standard features on here that all CD players would have, such as program mode, shuffle play. If you're in shuffle play, it will pick another track at random. Where is it here? There's the next one there. Play all the tracks and then stop. Or if you push the repeat button, it would then repeat all the tracks. Once it got through all the tracks, it would then start over and play them at random mode again. Play mode in program, you could pick specific tracks. So on this one, if I'm not mistaken, you just punch in the tracks you want. So you want to start out with track 5, and then you want to go to track 12, and then you want to go to track 18, and then track 1. It would play them in that order. As simple as that. Very nice machine. These ones here are actually quite sought after because it is one of the ES players. They were a fairly reliable transport, very simple, just the one belt. And that's pretty much all that ever goes wrong with these machines, other than the laser. There's a few things that go wrong with CD players. One of them is the loading belt and the little switches that detect whether the mechanism's loaded or not. That's one of the things, and that's what went wrong on this one. Spindle motor and the laser pickup. If it's skipping, it's usually either the spindle motor itself or the laser pickup. And what happens with the spindle motors is the bearings or the bushings wear out, and the disc, the actual shaft can start to resonate, which will translate into vibrations on the disc, cause the laser not to read. They can also, the bearings themselves can get sticky, or they won't spin up to the correct speed, and then you'll end up with the disc that kind of spins a bit and then stops, and it doesn't read the table of contents. Of course, that can be the laser pickup as well that causes that. Laser pickups can fail for multiple reasons. One of them is that the laser diode is getting weak. That's one of the reasons that they fail. Another reason that they fail, though, is because the lens gets dirty. So the laser lens, of course, is facing up, and dust can drop on it. Now you can dust them off. That's the easy part, is you can dust them off. But if the optics internally get clouded, such as when people allow smoking in their homes, that smoke will get down into the internal optics and can create a film on them which will obscure the laser. And when that happens, well, there's not enough laser light getting through. You end up with a CD player that won't read, or it skips. Other problems that quite often happen on these units is, well, sometimes that flexible cable that connects the optical pickup to their servo board, that can fail. It doesn't happen that often. It does happen, but more often than that, the cause of skipping on these units is a cracked gear right down here. See if I can get my camera in close. We'll do an inspection on this one while I've got it apart. This gear here on the motor can crack. Now you see what Sony has done to try to mitigate that on this unit is they've got a gear that's got slanted teeth. That's to try to mitigate the gear itself failing. A lot of the gears that were straight cut, what would happen is you would get a crack that would start usually on one of the molded pieces here where the gear was injection molded. The plastic shrinks over time and it can crack, and when it does, the gears that are cut straight, it will split right down the entire tooth and cause the tooth to open up a little bit wider. When you're searching, no problem, because the motor's coming on at a relatively high torque, but when the unit is playing, this turns very, very slowly just to move the sled slightly as it's playing. And what happens is when that crack, because the teeth have opened up slightly, meets the teeth of the other gear, it sticks. And then it'll stick and it won't move. And the laser can only track so far. It's getting to the extreme part of its tracking. It's screaming for the sled to move. The servo cranks up the voltage a little bit to the sled, and then it jumps forward. It overcomes the resistance from the crack in the gear, and it skips forward, and the laser moves too far, and your disc skips. That's the number one problem. If you've got a CD player that is skipping, and it's skipping after, plays fine for the first couple minutes, and all of a sudden it skips, and it'll play fine for another couple minutes, and it'll skip again or get hung up, it's usually the teeth are damaged. Or there's a grain of sand that's gotten into the gears, and that can happen too. Get a grain of sand into any of these gear teeth, and it can cause them to stick. So you need to inspect and make sure that there's no grains of sand. That's more problematic when you get into locations where there is a beach involved, like where I am, and there's a gear down below as well. Typically a grain of sand in that one though is not going to cause a problem because the torque is quite high by the time it gets there. If you're going to have a grain of sand cause a problem, it's usually on this primary gear or in the motor. Anyway, this one's done. Thanks for watching. We'll catch you in the next one. Bye for now.